Good day, everybody. This is Dr. Nandi again. So, you want to listen to a joke about a statistician? Why did a statistician win a lottery? Because they knew all the odds against them. Okay. And the second one, why did the statistician not get invited to a party? Because he always skewed the distribution or the conversation in his favor. No, kidding aside, let's get back to completing our discussion on hypothesis testing. So just to remind you what happened, that I said that the null hypothesis is the status quo and we'll assume that it is true at the start of the hypothesis testing. Just like we assume the defendant is innocent in a jury-based trial system. Okay. That being the case, in our case, the null hypothesis, the mean population mean age is 22, equal to 22, and alternate, which is the opposite of that, is the population mean age not equal to 22. So because we cannot reach the entire population, we made this educated guess or hypothesis statement about the population mean age. Now we are going to test it out. How are we going to test it out? What do we mean by testing it out? We want to test how appropriate our educated guess is. Okay. Is it in the right ballpark? Is it in the right ballpark? That is the big question. So we collected, remember, a simple random sample of size 36, and we found the sample mean age to be 21. Okay. So we wanted to construct or to calculate the standard normal score of the sample mean age of 21. Just to remind you, the standard normal score is calculated by taking the difference of x, value in the population, from the population mean divided by standard deviation of the population. But here that is not happening. We are comparing the sample mean with the value in the null hypothesis, with the hypothesized value of the population mean. So to make things straight, we should divide it, the difference of the sample mean from the value in the null hypothesis, the difference, we should divide it or standardize it by the standard deviation of the sampling distribution of X bar. That's where we were last time. Okay, so I will share my screen with you. So let's write the null hypothesis again. The null hypothesis H sub 0 is mu equal to 22. The alternate is the mean is not equal to 22. It's similar to, I would say, jury-based trial system where the null hypothesis, the defendant is equal to innocent, and the alternate, the defendant is not innocent. Along the same lines, our null hypothesis mean is 22, mean age, and the alternate, that is the null hypothesis, alternate is hypothesis is mu not equal to 22. And just to remind you, we collected a sample of size 36, simple random sample of size 36 from the population. The sample mean came out as 21, and we know the standard deviation, that is an average variation in the age from the mean of the population, is just 1. We also calculated sigma x bar, which is the standard deviation or standard error of the sampling distribution. Remember, this is the standard deviation of the sampling distribution. That is how far on the average sample means deviate from the population mean. Remember, the center of the sampling distribution is the population mean. So how far do sample means vary from the center, population mean, on the average? That is your standard error, and it is given by sigma divided by square root of n, And in our case, sigma is 1 population standard deviation in ages divided by square root of 36, which is 1 over 6, which is 0.167. So we want to calculate a z-score. So calculate a z-score for the sample mean. For the sample mean. So z will be given by, let me write it over here, is x bar, how far the sample mean is located from the value in the null hypothesis. Remember, this is mu sub 0, 0 subscript, same as h sub 0, subscript 0, null hypothesis, divided by sigma divided by square root of n. This whole thing is known as standard error, or it is the standard deviation of the sampling distribution of the mean, sample means, which is x bar is 21 minus mu sub 0 is 22 divided by, we already calculate sigma divided by 10 square root of n, or sigma x bar, which is the standard deviation of the sampling distribution, is 0.167. So in the numerator, we have 21 is less than 22. So it is minus 1 over 0.167. Okay. So let's calculate that. We're using again the calculator. 0.167 is 5.98. Negative should be negative 5.98. So let me, oops, is this? Okay. And let me move my screen up. So let me draw you the standard normal distribution. So I'm going to draw a standard normal distribution. That is a z distribution basically. So this is the horizontal line. Sorry, let me erase the. Okay, so that's a z scale. At the center, z is equal to 0. And you have a bell-shaped distribution like this. Something like that. So my drawing is a little bit off, so let me erase that. So at the center where the peak is the highest, that is somewhere around here, z is equal to 0. Okay. This is the standard now. So we have probability density on the vertical axis, or probability. Okay. Remember our z-score came out as minus 5.98. So this is far away in the, somewhere in the tail region, far away from the center. So somewhere over here, assuming this is the minus 5.98. Now we want to find out what is the probability of getting a test statistic at least as extreme as minus 5.98. That is, minus 5.98 is the highest. It can be more extreme, that is more negative. So basically, we want to find out. Now, remember our null hypothesis. So if I, okay, so this is called a two-tell test when we have equal to, not equal to. This is called a two-tell test. This is a two-tell test. Let me just write it better. So this is two. two-tail test. When we have equal to and not equal to, it is a two-tail test. Remember, not equal to means we do not know for sure whether mu is greater than 22 or mu is less than 22. We just know it is not equal to. So in this case, in the two-tail test, what happens is we will assume positive 5.98 on the right tail also and a negative 5 point, and we will find. So p-value in a two-tail test is the sum of the probability on the left of the test statistic, left of calculated z. If it is negative, or no, not or, so let me, is this sum of the probabilities and the area to the right of the positives test statistic, to the right of positive z. Now you are asking what is, I use two terms, so let me clarify this. So let me change the color of my ink. Oops, sorry. Let me erase this. So let me go. Now, before I go back, let me move this a little bit. So, first of all, the z-score that we calculated was equal to minus 5.98. This is actually called the test statistic. It's a characteristic of the sample that we have gathered. Of the sample we have gathered. We have gathered. And I also use the term p-value. P-value is equal to probability. P stands for probability value of getting a test statistic at least as extreme as what we have obtained. So remember, in our case, this is a two-tail test. So it will be this. So let me draw again the z distribution. Nope, this is no good. So this is z equal to 0 at the center where the peak is the highest. This is the z-axis on this side. And we calculated a negative z-score of, say, minus 5.98, which is, if you extend the curve, this is half of the p-value. And we will assume, because it's a two-tail test and we do not know for sure whether it is greater than or less than, there is an equivalent value on the right also. This is positive 5.98 and this is half p. So our goal is to find the sum of the two areas, sum of the two highlighted areas. And this is only true for two-tail test, which is not equal to. For two-tail test, remember, this is coming from the fact that we do not know whether it is greater than or it is less than. We just said it is not equal to in the alternate. So now we can use our calculator easily, for example. So let's find the area. Find the area to the right of or to the left of minus 5.98, okay, under the standard normal curve. And that is easy for you if you have a TI-84. I suggest you use a TI-84. You can, of course, always use tables if you like. And in TI-84, okay, let me change the color of the ink, maybe to a purple, okay. And we will press in TI-84, second verse, number 2, which is normal CDF. That is area. C stands for cumulative density function. Density function. Probability density function, that's where the name is derived from. So our lower on the left is minus 1 E99. This is always the calculator is set at that. That means a very large negative number on the left, minus 1 followed by 99 zeros. My upper is minus 5.98. That's where I'm stopping. My mu is 0 and my sigma is 1. Then I will put my cursor on paste and hit enter twice. Okay. So let me move this. Oops, not this. Okay. Okay. So let's see how much is that area. So second, then verse key, then number 2. My lower is minus 1 E99. My upper, I'm stopping my calculation at minus 5.98 in my area calculation, which is the probability under the standard normal curve. Mu is 0, sigma is 1, paste, enter and enter. And that's a very small p-value. So that p-value, half p-value I should say, is equal to 1.1 E minus 9. What does it mean? 0.8 zeros and then 1. So complete p-value is twice, 2 times 1.1 E minus 9 or 2.2 E minus 9. Again, that means, as I told you, is first 8 zeros after the decimal place. And then 2. This is almost equal to 0. Okay, so p-value is equal to 0. Now, here we have to bring in the concept of level of significance. So, level of significance. So, level of significance usually, what is level of significance? It's written as alpha. It is the maximum risk of rejecting H0 when it is true. H0 when it is true. So usually alpha is 0.05. That is, we take a maximum risk of 5%. Then compare. So let me change the color back to red. Compare p-value with alpha. Remember, my p-value is 0. My alpha usually is 0.05. So in this case, p is less than alpha. Decision, reject H0. Remember my H0? Mu is equal to 22. Okay. So that means we have enough evidence to support the at alpha equal to 0.05, there is enough evidence to support HA, to support HA. What is the HA? Colon mu not equal to 21 and 22. Or in other words, think of the practical aspect of this. That means the sample with a mean of 21 could not have come from a population whose mean is 22. That's why we are rejecting the null hypothesis, because our null hypothesis mu is equal to 22. The test statistic is too far away in the left tail. That is, the sample mean is located far away from the hypothesis value in the null hypothesis in the left tail. That means the sample with a mean of 21 could not come from a population with a mean of 22. So, therefore, we reject the null hypothesis and support the alternate, that is mu not equal to 22. The probability of getting a test statistic as low as 5.98 is very small. This cannot happen if the sample would have come from a population with a mean of 22. Hence, the sample did not come from a population with a mean of 22, or we reject the null hypothesis and support the alternate. Okay, that's what it is all about. The sample did not come from a population with a mean of 22, therefore reject the null hypothesis and support the alternate. I stop here today. Any question, any comment, please write me a comment. I will get back to you as soon as possible. And please like my video. I appreciate it. Please give me a thumbs up. And thanks for supporting my channel by subscribing to it. Please do subscribe to it. I really appreciate that. And please do not forget to watch me tomorrow when I'll be back with another interesting video. And please share my video with your friends. Appreciated. Much appreciated. Thanks again. Take care. Have a nice day. See you next time.